Irrespective of addition or subtraction, the absolute error in your final result should be the sum of it. How do we calculate relative error? It is given by R is equal to delta A mean divided by A mean. This is how we calculated relative error. Either you multiply or you divide two quantities. The relative error will be sum of relative error in the two individual quantities. Any physical quantity raised to the power 2 or raised to power k will be k times. Hello everyone. I am Nishma Nanjamma, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome back to everyone for my today's session, that is session 3 on chapter 2, units and measurement. So far we have studied what is error, what are the types of error, what is unit and what are measurements. So every measurement involves uncertainty, which is called as error, and we have solved numericals based on errors. So today's session I have come up with combinations of error. So what do you mean by combinations of error? That we'll be discussing in today's session. So generally, experiment involves measurement of several physical quantities. The result of the experiment obtained by performing mathematical operations like addition, subtraction, multiplication, exponential, etc. To understand this, let's take an example. Consider I have a liquid. I should calculate what is the volume of liquid. So I am performing an experiment. Volume, length, mass are the physical quantity. So volume of the liquid, I have to calculate what is the volume of a liquid. So to calculate volume of the liquid, what is the formula for volume? It is length into breadth into height. So all these are physical quantities. So I have to measure what is the length, what is the breadth, what is the height. So I'll get what is the volume of the liquid. So I am performing multiplications. I am multiplying length, breadth, height. I am performing mathematical operations to calculate what is my volume of liquid. So this final result of the volume, you might get 24.56 or 24.67. Some volume answer at final you will get some answer. So this answer is not 100% accurate. All measurements will have some uncertainty. So this uncertainty is nothing but error. So every measurement will have an error. How this error combine in the final result, how this error generating error in the estimation of volume, that we'll be discussing in today's session. So combination of error, how errors will combine in the final result when you perform mathematical operations like addition, subtraction, multiplication, etc. So in combinations of error, the combinations of error in various mathematical operations are as follows. The first one is error of sum or a difference. Error of a sum or a difference, that is addition or a subtraction. So second one, error of product or a quotient, that is we are multiplying or dividing. Third one is error in case of measured quantity raised to a power. Error in case of measured quantity raised to a power, that is exponential. We are dealing with exponential in the C, in the point C. So first we'll start with error of sum or a difference. Let us try to understand what is error of sum or a difference. So error of sum or a difference is nothing but addition or subtraction. This is my first rule. So rule 1. Rule 1 says that, listen carefully, when two quantities are added or subtracted, the absolute error in the final result is sum of absolute errors in the individual quantities. So what you can understand? I'll repeat. When two quantities are added or subtracted. So my first rule is a specification about addition or subtraction of two quantities. So it is a specification about addition or subtraction of two quantities. When you add or when you subtract two quantities, the absolute error in the final result. The absolute error in the final result. I am doing a measurement. I am adding or subtracting two quantities. I am performing a measurement. So I have told you earlier in the previous sessions that every measurement you make will have an uncertainty. This uncertainty is nothing but a error. So it will have an error, though the error in the final result, due to addition of two quantities or due to subtraction of two quantities is nothing but the absolute error, So this absolute error which you have got is due to sum of absolute errors in the two individual quantities. Either you add two quantities or you subtract two quantities. So absolute error in the final result. So in the rule 1, in the sum or difference, you are talking about an absolute error. You are considering absolute error in this rule 1. Sum of absolute error in the two individual quantities. So you can have a doubt. Ma'am, if I find out the difference of two quantity, that I am subtracting two quantities, should I have to find out the difference of absolute error? Should I have to get the difference of absolute error of two individual quantity? No. Either you add or you subtract, I don't bother. Irrespective of addition or subtraction, the absolute error in your final result should be the sum of, it's not the difference of, it is sum of individual quantities, sum of absolute errors in the individual quantities. So, let us try to understand this mathematically. I'll put it out in mathematical way. Consider, when two quantities are added or subtracted, let us consider two quantities, say A and B. Now I have two quantities, say A and B. So the measured value of these two quantities A and B, what will be the measured value? Measured value of A and B are A plus or minus delta A and B plus or minus delta B. So, Z is equal to A plus B. I am performing summing up. I am performing addition operation here. I have two quantities. Listen carefully, A and B. I am measuring the two quantities A and B. So, the measured value will be A, that's the quantity, plus or minus delta is nothing but the error in my measurement. This is error in my measurement, and I am measuring the second quantity B. The measured value of B will be B plus or minus delta B. Plus or minus delta B, again here it is the error in my quantities. The quantity, the measured value plus its error, the measured value plus its error. So, error in Z will be Z plus or minus delta Z. Error in Z will be Z plus or minus delta Z is equal to, what will be my A now? A is nothing but A plus or minus delta A plus, what is my error in B now? Measured value. B can be substituted as B plus delta B. This was the quantity. After the measurement, you will reduce the equation to so and so. Now, how will you add this? How will you add this? Z plus delta Z is equal to, how will you add this? A plus B plus or minus delta A plus or minus delta B. You can see here, there are two quantities A plus B plus or minus delta A plus or minus delta B. So, error will be delta Z is equal to delta A plus delta B. So, error at the end, that is the absolute error that I am considering in rule 1. The absolute error will be sum of two absolute error in the individual quantity. Quantity A, quantity B. There are two individual quantity. So, delta A, this indicates that it is an error. So, absolute error in my final result is the sum of, you can see it is the sum of absolute error of two individual quantity. This is what rule 1 is trying to tell us. Similarly, you can perform for difference and see what you will get the answer. If it is a difference, you will consider Z is equal to, You can consider A minus B. You are finding difference. Sum is over. Perform the similar operation and see what you will get for difference. For difference, it will be Z plus delta Z is equal to, here you will have A minus B plus or minus delta A plus or minus delta B. You can see either you subtract or you add the two quantities, the error will be sum of. The error will be, again you will get delta Z is equal to, if you see the error, it is delta A plus delta B. So either you add or you subtract, the error will be, the absolute error will be the sum of absolute error in the two individual quantity. Either you add or subtract, I am not bothered about that. Irrespective of addition or subtraction, the two quantities are added or subtracted, the absolute error in the final result is sum of absolute error, in the individual quantities. So this is the rule 1, that is error of a sum or a difference. I hope it is clear for you all. So to understand this much better, let us solve a numerical. Here I have a numerical on rule 1. Try to understand this clearly. The temperature of two bodies measured by thermometer are T1. It is T1 is equal to 20 degrees Celsius plus or minus 0.5 degrees Celsius. And what is T2? T2 is 50 degrees Celsius plus or minus 0.5 degree Celsius. Calculate the temperature difference and the error. Calculate the temperature difference and the error. Hope the rule 1 will be clear for you. Try to solve it with me. They have given two temperatures here, T1 and T2. So here you can see 20 degrees Celsius and 50 degrees Celsius are the measured value. So this is my measured value. Whatever it is given with plus or minus 0.5, is my error in the measurement of temperature. So it might be 20 plus 0.5 degrees Celsius or 20 degrees Celsius minus 0.5 degree. The error might be plus or minus. So whatever measurement you are doing for temperature has plus or minus 0.5 ka error in it. So you know what is the measured value, you have your error now. So how will you calculate using rule 1? They have asked you to find out the difference. So difference is given by delta T. Delta is the difference. Difference delta T is equal to T2 minus T1. T2 minus T1. So what is T2 here? It is 50 degrees Celsius minus 20 degrees Celsius. The error always will be, absolute error will be sum of absolute error in the two individual quantities. So error will always be the sum here, 0.5 degree. So they have asked me to find out the difference and the error. The difference is what? 50 minus 20 is 30 degrees Celsius plus or minus my error, absolute error. You can go through here. The absolute error in the final result, is sum of absolute error in the individual quantity. That is sum of absolute error in the individual quantity. I mentioned you clearly, I am not bothered whether you add or you subtract them. They have asked you to find difference. Either you subtract or add, the error, that's the absolute error in the final result, will always be sum of, it will always be added. Sum of errors in the individual quantity, T1 and T2 are the individual measurement of temperature. So the error will be added up. So it will be 1 degree Celsius. So this is your answer. I found out what is the temperature difference and also I found out what is the error in the measurement. This is how you understand the numerical and try to solve by yourself. Given to temperature, they have asked you to find the temperature difference. I have found out what is the temperature difference. T2 minus T1 gives me delta T. That's difference in temperature. But the error always adds up. The final error is the sum of absolute error in the two individual quantity. So summing up of two errors, I have got 1 degree Celsius. Since I have found out difference, should I have to subtract them, ma'am? Should I have to find the difference of the error, ma'am? No. Either you subtract or you add, you always find out the sum of absolute error in the two individual quantity. It is always sum of absolute error. Keep in your mind. So this is your answer for the numerical 1. Next, rule 2. We have rule 2. Error of a product or a quotient. Error of a product or a quotient. That's I'm talking about multiplication or a division. Let us read rule 2. When two quantities are multiplied or divided. When two quantities, say A or B, A and B are the two quantities. When they are multiplied or they are divided. They are multiplied or divided. The relative error. Listen carefully. In the rule 1, we are talking about the absolute error. The sum or the difference, the absolute error was there in the final result. Here, multiplication or division, the relative error in the result, sum of relative error in the multipliers. That is two individual quantities. Similar to rule 1, in rule 1, we are considering absolute error in the final result. And in rule 2, in multiplication and division, we are considering relative error. There we were talking about absolute error and summing of them. Similarly, we are talking about relative error and summing of them, not multiplying or dividing. We are adding the relative error in the two individual quantities. So let us try to understand this mathematically. Okay. When two quantities are multiplied or divided, when two quantities, let two quantities be A and B. Let two quantities be A and B. So, two quantities are multiplied or divided. So, Z is equal to, I will take multiplication first. Division you can do for yourself. You can do it by yourself. Similar to multiplication. So, I am multiplying or dividing. I am taking multiplication to show you how it comes out mathematically. The relative error in the result is the sum of relative error in the multipliers. So, these are the two quantities A and B. So, measured value of A and B will be A plus or minus delta A and B plus or minus delta B. So, two quantities A and B. The measured value, after you measure them, there will be some error, there will be some uncertainty in your measurement. So, A is given as A plus or minus delta A, measured value plus or minus its error, and B plus or minus its error, delta B. Now, how will I write this? So, error in Z is equal to, how will you write this? A plus or minus delta A into B plus or minus delta B. Okay. So, this will be Z plus or minus delta Z. So, error in Z is equal to, this is Z is equal to A dot B, A into B. Error in Z, I am measuring Z, Z is equal to plus or minus delta Z. So now how will you multiply this? So, this is your LHS, this is your RHS. Divide LHS by Z and RHS by AB. Now, divide them by Z and divide RHS by AB. Now, what will you get? So, here you will get plus or minus delta Z is equal to, what you will get here? First, you have to multiply them. How will you multiply? You will take A, multiply B, you will take A, multiply delta AB. So, first you multiply them and then divide. So, A, AB plus or minus A delta B Take the second one, multiply first term, multiply second term. Plus or minus delta A B plus or minus delta A delta B. I have taken the first term, I am multiplying the first term and second term. Take the first term, multiply the first term, second term. A delta B, delta A B, delta A delta B. Now divide them by AB. So what will you get? Here it will get 1 plus or minus. Only divide A and A term. Don't divide delta A with A. So divide AB here. What will you get? You have only A. So delta B by B plus or minus. Divide delta A by AB. So delta A cannot be divided by A. You can divide B by B. So it will be delta A by A again plus or minus. This you can divide it as delta A by A and delta B by B. So since delta A and B are small, the product of delta A and B are neglected. Since A and B are small, the product of delta A and delta B are neglected. After neglecting these terms, you will get it as delta Z. Divide delta, here divide delta Z by Z. So you will have delta Z by Z is equal to 1 plus or minus. So you will have delta B by B plus or minus delta A by A. You can write plus or minus here. So this is your error. How you represent relative error? Delta Z by Z, delta B by B and delta A by A. This is your relative error in the final result after you perform the multiplication of two quantities. I will repeat. You consider two quantities A and B. The two quantities are multiplied here. Z is equal to A into B. The relative error that we have got, relative error, you can also write this equation as delta Z by Z is equal to, I am putting it in order, delta A by A plus or minus delta B by B. So the relative error in the result, will always be the sum of relative error. It will always be sum of relative error in the two individual quantities. In the two relative errors are summed up. Two relative errors will be the sum of relative error in the individual quantities. So this is about the error of a product or quotient. Simply, it is easy to analyze. Just go through rule 2. When two quantities are divided or multiplied. So, I am not bothered whether it is divided or it is multiplied. The relative error in your final result, will be sum of relative error in the two individual quantities. Relative error in A, relative error in B will be added up at the end of the result. That is what is my rule 2 trying to say us. So, this is rule 2. Either you multiply or you divide. The error should be sum of relative errors. It should be summed up. So, you can ask, ma'am, I am dividing or I am multiplying. So, my relative error should be multiplied or divided at the end. No, ma'am. No, it is not divided or multiplied. It is the sum of relative error. You do any operations, here it will be sum of relative error at the end. So, this is about error of product or a quotient. So, here you have a numerical where you can try to understand rule 2 much better. So, the resistance R is equal to V by I, voltage by current. So, this is your Ohm's law. This is Ohm's law. R is equal to V by I is given by Ohm's law, that you will be studying in the upcoming physics sessions. Don't worry about that. R is equal to V by I is your Ohm's law. And the SI unit for resistance here it is Ohm, represented by this symbol. SI unit for resistance it is Ohm. The resistance R is equal to V by I, where V it is given V is equal to 100 plus or minus 5 volt, and I it is given, and I is equal to 10 plus or minus 0.2. 0.2 is your error. Or V is the unit for voltage and A is the unit for current. It is ampere. A is the unit for I and V is volt is the unit for voltage and R is given by ohms. It's unit for R. So, how will you calculate? They have given R is equal to V by I. Find the percentage error in R. Find the percentage error in R. So, first I have to calculate individually V and I. Individually percentage error in V and percentage error in I. So, percentage error in first one I will consider V. Percentage error, it is given by symbol. It is given by symbol delta A. So, what I will do here is to calculate percentage error. In our previous session, errors, we studied what are relative error and what are percentage error and how to calculate it. There is a formula. How do we calculate relative error? It is given by R is equal to delta A mean divided by A mean. This is how we calculated relative error. Delta A mean by A mean. Mean absolute error, the ratio of mean absolute error to the error in the quantity, mean error in the quantity measured. So, you have it here. What is delta A5? You have 100 and plus or minus 5 is your error. So, 100 is your measured value. How will you always obtain mean absolute value? First, you take arithmetic mean. Once you get arithmetic mean, you will subtract that individual quantity with the true value. Arithmetic mean is your true value. Individual quantity subtracted by true value will give you mean, will give you absolute error. So, this absolute error is again taken mod, magnitude is taken and it is divided by number of trial, that will give you mean absolute error. So, this mean absolute error here, it is 5 divided by 100. 100 is my mean, 5 into 100%. Percentage error they have asked. So, 100 is cancelled out and you will get 5% and you will get 5%. Similarly, how will you calculate percentage error? You can write this 5 is equal to, for voltage percentage error, you can multiply, you can represent it as with this symbol. Similarly, you will calculate for delta. I am representing percentage error for current in this way. That is equal to, what will be here? 0.2 mean absolute error in the measured quantity. That is 0.2 divided by 10 into percentage error. Relative error multiplied by 100% will give you percentage error. So, what will you get? It is 2%. It is 2%. So, I have I is 2% and voltage it is 5%. Now, they have asked to find the percentage error in R. R is equal to voltage by current. So, how will you find voltage by current? Now, it is in the division format, V by I. So, you know what is V? It is 5. And what is I? 2%. So, should I write it 5 by 2? If I write 5 by 2, it will be like I am not following my rule 2. That is multiplication and division. That is I am violating my rule 2. What rule 2 says? Either you multiply or you divide them. The error which you have got here, the relative error which you have got here, that relative error at the end which you have got will be sum of error in the two individual quantities. So, this is wrong. So, when it is in division or it is in multiplication, I should write it as 5% plus 2% will give me 7%. So, either you divide or it is in the multiplication format. Whether you divide or multiply, the relative error will be the sum of errors in the two individual quantities. Summing of two relative errors, I have got 7% error in R. Resistance has 7% of error. In the rule 2, we will be talking about relative errors. So, relative error will be the sum of, it will always be added. Even though it is V by I, when it comes to the rule 2, the V plus I, it will be error in the V and error in the I. That's two relative error in the individual quantities are added up and we are getting 7% as the error in percentage error in R. So, the next we have two resistor of resistance R1. So, it is given R1 is 100 plus or minus 3 ohm and R2 is 200 plus or minus 4 ohm. So the two resistors R1 and R2 of resistance, these values are connected in series and parallel combination. Find the equivalent resistance of series and parallel combination. Find the equivalent resistance in series and parallel combinations. So use formula. So you can write down with me. Use formula for series. It is represented by Rs is equal to R1 plus R2. Series is equal to R1 plus R2. For parallel, represented by Rp is equal to, for parallel you can write down R1 R2 divided by R1 plus R2. This is to find out resistance in series and parallel. When you have to find out equivalent resistance in series and parallel. With error, when it is with error, the formula for parallel will be delta Rp by Rp square is equal to delta R1 by R1 square plus delta R2 by R2 square. So this is to find out with error in the combination, we will find out equivalent resistance for series and parallel. Now use this formula for series. What it is? Rs is equal to R1 plus R2. What is R1 plus R2? 100 plus or minus 3 ohm. R1 plus R2. So it is 200 plus or minus 4 ohm. So what will be your Rs? It will be 100 plus 200. It is 300 plus or minus 4. 4 plus 3 is here. It gives you 7 ohm. This is resistance in series. Equivalent resistance in series combination. Rs. Now what will you do to find out parallel? Rp. It is represented by Rp. So Rp is equal to R1 R2 by R1 plus R2. R1 R2 is 100 into 200 divided by R1 plus R2 is again 100 plus 200. This is just to find out equivalent resistance in parallel. So the answer you will get, you can check it with your calculators. It is 66.6 ohm. 66.6 ohm. Now to find out with error in equivalent resistance in parallel combination, we introduce a term delta. To calculate error in the equivalent resistance of parallel combination, we will introduce the term delta. How we will find out now error in equivalent resistance? That is why we use this formula. This formula delta Rp by Rp square is equal to delta R1 by R1 square plus delta R2 by R2 square. So how will you calculate error in your equivalent resistance now? You got resistance in, that is equivalent resistance in series, it is R1 plus R2. You use formula, you will get 300 plus or minus 7 ohm. This one. When you can find out equivalent resistance in parallel you have two format. One is you will find equivalent resistance, that is 66.6 ohm. You can calculate this using your calculators, and to find out with error in the calculation of equivalent resistance in parallel, you introduce a term delta. To calculate error in parallel combination, you introduce this term. So take this term to that side. Take this term which is there in the denominator to RHS. So square is there, it will become whole square. We'll write it here. So it will become delta Rp is equal to, you can see here, when you take this term to that side, what will happen now? So Rp is going that side, Rp delta 1 will be introduced into here. So plus delta R1 plus, similarly you have one more term R2. So it will be Rp by R2 whole square. Whole square is why? Because you are bringing Rp to this RHS. You have square on both the sides, square. So it will be whole square into multiplication symbol again. So multiplied. You can see here, I want delta RP error in parallel combination. So I'll send the numerator term to RHS. So RP R1 square. So I'll take whole square into delta R1. Here again delta RP square will go that side. Delta RP by R2 whole square into delta R1. Now what will you calculate here? What is the value? RP have got 66.6. What is R1? It is 100. So 66.6 divided by 100 into, what is the error here? 3 ohm. So 3 plus, again, what is your RP value? 66.6 divided by, what is your R2? It is 200. What is error in R2? It is 4. So 200 into 4. So your delta RP will be 1.77 ohm. You can calculate using calculators. Resistance symbol, it is SI unit is ohm. So 1.77 ohm. Now how will you write the error in parallel? So RP is given by 66.6 plus or minus 1.77 ohm. So error might be plus 1.77 or minus 1.77. This is the error in the parallel combination. Look at here. Series and parallel has formula R1 plus R2 and R1 R2 by R1 plus R2. I have calculated what is equivalent resistance in series and parallel. In series I have got 300 plus or minus 7 ohm and in parallel I have got 66.6 ohm. So when I have to calculate error in parallel combination to get the overall equivalent resistance of parallel, so what I'll give? I'll introduce the term delta in parallel combination. So this is how you write error. When you talk about relative error, in rule 2 we are talking relative error. From the mathematical way we got to know how we represent relative error from rule 2. Delta Z by Z is equal to delta A by A plus or minus delta B by B. That is how you represent relative error here. So similarly I have represented relative error and I have taken what is error in parallel combination. I have substituted the values for RP, R1, delta R1, similarly for R2, and I got error in parallel combination and overall equivalent resistance in parallel, it is given by 66.6 plus or minus 1.77 ohm. This is your error involved in the measurement. This is about rule 2. Either you multiply or you divide them. The relative error will be sum of relative error in the two individual quantities. So next you have error in case of a measured quantity raised to a power. Error in case of measured quantity raised to a power. So what is this rule 3? Last rule. We'll read that. Relative error in a physical quantity raised to power k. Raised to power k. For example, I have z is equal to a power k. A is my physical quantity raised to power k. It is raised above a. It is the power of a. It is given a physical quantity raised to power k is k times the relative error in the individual quantities. It need not be k itself. It can be A, it can be B, it can be C. But in your NCERT textbook, it is represented with k times. So I have written k above A. So they ask, this is a physical quantity. Now, how will you write relative error? Z is equal to delta A by A. It is delta A by A to the power k. I had a physical quantity. So relative error in a physical quantity will be delta A by A. So relative error in physical quantity raised to power k is k times relative error. K times relative error in the individual quantities. So this is my rule 3. Even in rule 3, I am talking about relative error. My rule 2 was telling me about relative error and the first rule was absolute error, and even again in the exponential error in case of a measured quantity raised to a power, even here I am talking about relative error. I am considering relative error. Any physical quantity, say A, B, C. So the relative error in the physical quantity is represented by like this. So relative error raised to power k will be k times relative error in the individual quantities. Either you raise to the power or not, the error always will be k times. It will be k into, example you have a to the power 2. It will be 2 times a. So if it is relative error in a is nothing but delta a by a. So it will be 2 times the relative error in the individual quantities. Suppose you have a to the power 4 or a to the power half, it will be 1 by 2 of a. 4 of a, 4 times a. Similarly, k times relative error in the physical quantity a. So, relative error, listen, relative error, we are considering relative error here. The final result which you are getting will have relative error. Relative error in physical quantity is raised to power k. It is raised to power k. It is k times relative error in the individual quantity. It is k times the relative error in the individual quantities. If you have a to the power 2, it will be 2 times a. To understand this better, we will consider a numerical here. See, given you have z. You have z is equal to, calculate relative error in z. So, z is equal to, you have a4. So, how will you write a4? It is 4 times relative error is given by delta a by a. You got to know how we represent relative error. It's delta a by a. So, relative error in physical quantity a is 4 times this plus, you can see here, it is k times relative error in the individual quantity. So, it is 1 by 3 times relative error in B. So, here you can see it will be plus, there is no power here. So, it will be delta C by C. Again plus, it will be 3 by 2 times error in quantity D. So, you can ask me a question here. Ma'am, it is divided by. So, should I write 4 times A plus 1 by 3 times B, and it is divided. So, should I write divided by C times C and plus 3 by 2 D? No. If you do like that, I will violate my rule 2 will be false. I am not following my rule 2. What rule 2 tells? Relative error should be sum of errors in the individual quantity. Either you divide or you multiply them. Either you divide, it is in the division. It is in the division format, AB by CD. Either you divide or multiply them. This is the wrong way. This is, I am violating rule 2. So, this is my right way. Either you divide or multiply. At the end of the result, the relative error, even here we are considering relative errors. My relative error will be sum of error in the individual quantity. So, if you have 4, it is 4 times relative error in the quantity A, 1 by 3 times relative error in quantity B. This is how you write relative error. This is the error in B. After measurement, you have relative error in B. So, C don't have any power. So, it is delta C by C is relative error plus C, D, physical quantity D has power 3 by 2. Instead of K, you have 3 by 2. So, it is 3 by 2 times error in D, delta D by D. So, either it is in dividing or multiplication. I need not put divide or multiply symbol here. Relative error will be sum of the two individual quantities itself. Irrespective of addition or division, my relative error, since I am talking about relative error in rule 2 and rule 3, relative error also will be sum of the two errors in the individual quantities. So, this is about exponential term rule 3. So, next you have a numerical. See, in this numerical, he has asked me to calculate period of oscillation. Period of oscillation of simple pendulum is given by T is equal to 2 pi root of L by G. Measured value, that is L is given 20.0 centimeter. Known to 1 millimeter accuracy and time for 100 oscillations, that he has given N, it is 100 oscillations of pendulum is found to be 90 second. T is given, it is 90 second time using wristwatch of 1 second resolution. What is the accuracy in determination of G? Accuracy in determination of G. So, carefully listen. He has given 1 millimeter accuracy in length and 1 second resolution in time. That is 90 seconds. That means here my delta L is given 1 millimeter accuracy. So, length is in 20 centimeters. So, it is in millimeter. Convert to centimeter. So, what it will be? 1 into 10 to the power minus 2. Shift 0. It will be 0.1 centimeter. 10 to the power minus 3 is millimeter. So, when you shift one more 0, it will be 0.1 into 10 to the power minus 2. Minus 2 is for centimeter. So, since length is given in terms of centimeter, so this length has 1 millimeter accuracy. That means my delta L is given. So, delta L here is 0.1 centimeter. From millimeter, I have made a conversion to centimeter. He has given N is equal to 100 oscillation and 90 second. That is my time T is given. Now, in this 90 second, wristwatch has 1 second resolution. That means my delta T it is given 1 second. So, delta T is given, it is 1 second. I should calculate T here. In this T is asked me to determine accuracy of G. So, my equation will reduce to G is equal to, you have square root. So, it is 4 pi square L by T square. Now, how will I calculate? So, I should calculate accuracy in determination of G. That is, I should find out error. Delta G is equal to delta L, because 4 pi square it is constant. It is a constant term. Pi is 3.14. 4 pi square is a constant. So, I have L by T square. So, I will write delta L by L plus, either you multiply or you divide. Relative error will be sum of. So, it will be plus, you know power exponential rule. It will be T to the power 2. Any physical quantity raised to the power 2 or raised to power K will be K times. So, it will be 2 times delta T by T. Relative error of physical quantity. So, what will it be your delta G by G is equal to, what is delta L here? It is 0.1 divided by what is L? 20 plus 2. What is delta T here? Delta T is given by 1 second plus or minus 1 divided by small t, it is given 90. So, here you can see it is plus or minus. Since it's error, it can be plus or minus, and even t it can be plus or minus. Since error can be plus or minus, it's denoted by plus or minus 1, plus or minus 0.1. So, you have a pendulum. You can see metal bob. When metal bob is applied some force, that is oscillating. It is oscillating 2 or 4th movement of a metal bob. So, there is a oscillations. So, he has asked time period for oscillation is T 2 pi root L by G. So, L it is given 20. So, in L you have 1 millimeter accuracy. I am converting millimeter to centimeter because this is in centimeter. How did I do the conversion? Millimeter is 10 to the power minus 3. So, 0.1, 10, shift 1 point. So, it will be 0.1 into 10 to the minus 2. Minus 2 is nothing but your centimeter. Since delta L is error, it is denoted by plus or minus. So, you have T is given for 90 second, wristwatch has 1 second resolution. So, this is your resolution in watch. So, this is your error. Delta T is plus or minus 1 second, and he has given that is 100 oscillations. For how many oscillations? 20, 30, 40. Similarly, 100 oscillation. How many number of oscillation is given? So, error you have to calculate. You have to calculate accuracy. Accuracy, error in determination of G. So, what is error? How will you calculate error now? So, delta G by G, I have reduced the formula to this. So, 4 pi square is constant term. Remaining is L by T square. When it is L by T square, how will you write? Delta G by G is equal to, use your relative error. Delta L by L plus or minus anything to the power exponential is 2 times the relative error. 2 into delta T by T. Substituting the value. Next, what will you get? So, delta G by G is equal to, you had 0.1 plus or minus 0.1 divided by 20 plus, what did you have here? 2 times plus or minus 1, that is 1 second divided by 90. Error divided by 90. So, you will get 0.027. Now, you got the relative error. How will you calculate percentage error? So, percentage error, if you want to calculate percentage error, it is relative error into 100%. That is 0.027 into 100 will give you 2.7%. So, you can approximately write. In the next session, I will tell you how you approximate the given result or final value. How you round up this significant value. I'll tell you what are significant figures and how you round up digit in your next session. So approximately I can write 2.7 as 3%. So your percentage error is 3%. So relative error is 0.027. So this is how you calculate relative error, and something to the power is represented by 2 times or k times that particular physical quantity. So relative error is given by delta T by T or delta L by A or delta A by A or delta B by B. Something to the power is power times or k times that particular value, that is exponential term. So students, in this session we have studied what are the combinations of error, how error combine in the final result. There are 3: error of a sum or a difference. So either you add or subtract 2 quantities, we are considering absolute error in the final result will be sum of 2 absolute error in the individual quantity. And the second rule we learned that we are talking about relative error, error of a multiplication or a division. So in that we learned that either you multiply or you divide 2 quantities, the relative error will be sum of relative error in the 2 individual quantities. We went through the numericals, and again in the third rule we learned that anything to the power, anything raised to power is physical quantity raised to power k is k times the relative error in the 2 quantities. So T square is given by 2 times the relative error delta T by T in that quantity. So that is all about today's sessions. So we learned combinations of error. So once again I'll meet you all in my next session where I'll be teaching you about significant figures and how we round up significant figures. Until then, see you all. Have a nice day. Take care. Thank you.